So here we have our cantilever beam, and what we're going to do here is to calculate our reaction force. That's going to be right there at that fixed end, and we're going to label the reaction force there as RA to just say the reaction at A. Now if we look closely, we'll see this 200 newtons right there at the end of the beam, and we also have this 40 newtons per meter as our UDL that spans across 5 meters. Now to calculate our reaction force, because we'll need that, and then we'll do our shear force diagram, we're simply going to say the sum of all our vertical forces should be equal to 0. And what that will look like is, if we take the forces going upward and sum them, they should equal to the forces summed that are going downward as well. So the only force that we have going upward here is the RA, and that will be equal to our 200 newtons that's going downwards, and we'll add to that our UDL, so that's the 40, and it's span across 5 meters, so that's why we multiply the 40 times 5. Now when we sum this, we'll end up getting RA equals, so that's just going to be 200 plus 200, so RA is 400 newtons. So this here represents our reaction at the fixed end. So now if we were to draw the shear force diagram, let's do that. We are going to see where the 200 newtons at the very end, that's our starting point. So let's say right here at that point, that's 200 newtons. And because after that 200 newtons force, what we have going downwards is just UDL forces, for every meter, we're simply going to step down 40 newtons. So this one would look something like a straight line graph. And what that will represent here is at this point right here, at the first point, that's our 200 newtons that's going down. So that would be representing our negative 200 newtons right there. And then as we keep going down, we're just going to go down in steps of 40. So right here would be negative 240 at that point. And then we go to the next point, that's negative 280. Keep going, that's negative 320. And it will go down all the way until we get to this negative 400 right there at the end. And that would make perfect sense because our reaction is actually 400 newtons. So from that point right there, if we were to go back to the top like so, then that's back at 0, which suggests that our system is therefore in equilibrium. So in this section right here, we can just shade in that section. That's the bit that will be taken into consideration for us here. Now we're going to take this a step further in this next video and do the bending moment diagram. So check that video out.